Hi guys, my name is Mihai John. I'm a HVAC engineer, and in this video I would like to show you how this air handling unit is working. We all know that on the market there are many type of air handling units, but today I want to speak about this particular air handling unit, and I will start with the beginning. We all know the air handling unit is got a duct which allow the air to go into the building and to cool or to heat the premises or to ventilate the premises as required. Then you have the supply fan which supplies air into the building. You have the extractor fan which suck the air, and either way you can exhaust it or you can push it further to be recirculated. We also have the building management control, which is actually the brain of the air handling unit, which controls the air handling unit. We have inverters, sometimes we don't, but this one particular have inverters. So the inverter will take the information from the building management control, and it will control the speed of the supply fan and the speed of the extractor fan. This is an economical issue. Sometimes we can have only contactors to start the motors on DOL, which is not recommended, or we can start the motor with a soft starter or start delta. We're not going to talk about this today. If you go a little bit to the right hand side, which is, you'll see a yellow, and it's LPHW. This is the heater heat exchanger. It's the heating system heat exchanger. And then if you'll go a little bit to the right hand side, you have the cooling process heat exchanger. And then you'll go a little bit further, you have the white filters, because the air have to be filtered. And then if you go a little bit to the right hand side again, you'll get to the dampers. The dampers which will ensure that the right quantity of air will be take into the building and exhaust from the building, and also will decide how much air will be recirculated through the building. One step further, you'll find the extractor fan. The extractor fan have two functions: to recirculate the air through the building, helping the supply fan, or to exhaust the air outside. Then you have the smoke alarm. The smoke alarm, it is an alarm in case you have a fire into the building. The smoke alarm will turn off the supply fan, will close the fresh air intake damper, will close the recirculating damper, will open 100% the exhaust damper, and it will run the extractor fan to push out the smoke from the building. It's a special kind of safety circuit, this one. If you ever have a smoke into the building, obviously the extractor fan will run, and when the smoke and all will be fixed, then you have to go on the roof to clean the smoke sensors, and then to reset the sensor, and then the building management control will start the cycle from the beginning. And now let's see how these things work. Just imagine it's 7 o'clock in the morning, and then the building management control is got inside the software which covers the running time, the temperature that the air is supposed to be. There's a lot of sensors, and I explain to you one by one. First, let's say it is 7 o'clock in the morning and the BMS wake up. Then when the BMS wake up, the first thing to do is check the dampers. Now, considering the smoke alarm, it's okay, so we don't have any alarms. So the first thing you will do, you will check the dampers. You will send the signal, and the dampers will open and close from 0 to 100% and come back to their initial position. What would the damper do this? The damper have a motor, and the motor of the damper have some auxiliary switches. When the damper open, some of these switches are closing some circuits which will send the input to the BMS, telling the BMS that the dampers are healthy. So let's assume all dampers are healthy, we don't have any fault. So the BMS tested the dampers, it's all good and perfect. Then the BMS will start the fans. So the fans are starting. When you start the fan, and the dampers are just 10% open. The fresh air intake is 10% open. I'm taking only 10% because I don't want to lose the temperature from within the store. And the exhaust air damper pushes out 10%. I'm recirculating 90% of the air of the store. I just use 10% because I want to overcome the carbon dioxide problem. So I'm recirculating the air through the store. It's quite easy, so the air is recirculated through the store. But it came to the point where that's not enough. Let's say the temperature into the store start to raise up. It's the middle of the summer. I have 30 degrees outside, and 27 degrees inside the store. The building management control then will analyze the outdoor temperature, and it will sense that if I will open the intake damper more to take air from outside, you won't do any good because the air outside is 30 degrees. It's hotter than the air into the building, which is 27 degrees. So the only thing I can do just to bring hot, humid air, which will make the thing worse. So I will only open the damper 10% to suck the minimum amount of air, just to overcome, as I said before, the CO2. The same quantity of air should be exhausted, should be taken out of the building through the exhaust air damper, and the recirculating damper will be 90% open, just to make sure I'm not losing too much energy from the building. Then the building management control will call for the chiller to run. So the chiller will be called to run. Just imagine, I just want to tell you something very important. Sometime, there are many air handling units on the roof that uses one chiller, and because of that, the chiller might be functional before the BMS to call him to run. You already run because you have to provide cooling agent to another air handling unit. So anyway, let's assume that the chiller was already running. Then the building management control, as you'll see here, we have a three-way diverted valve, will divert the cooling agent so it will go through this heat exchanger, and it will control this bypass to provide enough energy into this heat exchanger to cool the air. As the air is circulating and it passes by through this heat exchanger, the air in this chamber will become cold. You will be sucked by the fan inside, and then automatically the air will become cold. And then the air will circulate all the time. You will push 12 degrees, will mix with 27, the temperature will drop, the average of the temperature will come back, will be circulated again, and I'm pushing, and I will circulate the air until the store will reach the right temperature. When the store will reach the right temperature, then the building management control will restrict the flow here, but not necessarily 100%, just enough to maintain the temperature into the store. If the temperature into the store drops and drops and drops, it will come to the point where the building management control will restrict the flow completely. And will restrict it because the temperature drops too much. And then it will bring it back if the temperature starts raising again. So you only play with a diverter valve, because the chiller works for multiple AHUs. If it will be only one AHU on the roof, then yes, it could activate the chiller as well, but the chiller sometimes got its own running protocol. Most of the time I've seen chillers running on their own control, but sometime I saw a lot of chillers running on this building management control command. So if the HU need it, we'll enable the chiller. So okay, now we have to change the scenario. Let's say it's a very cold outside and it is a winter and we don't need the chiller. we don't need the chiller. The chiller, it is off, and we don't need it because it is winter. Now, in this case, the building management control will sense the temperature outside. If outside it's cooler than inside, it's winter, it's very cold, but inside the store I have a lot of fridges, which can make a lot of problems inside. The temperature can be very low. But let's say it's very cold outside, I have 10 degrees outside, and inside the building I have 16 degrees. Obviously, I don't want to bring too much fresh air. I bring fresh air, the minimum quantity of fresh air approved by the law to overcome the CO2. And I'm circulating the rest of the air, quantity of the air, 90%. And I will exhaust only 10%. That's all I'm going to do. After ensuring this dampers position are as I described to you earlier, the building management control will call the boilers to run. Let's assume there are many AHUs and the boilers already running. They can be wake up by this BMS control, but if I have many AHUs, each AHU can wake up the boilers because they work independently, and the AHU provide heating agent to all the AHUs onto the building, not only to one. Then this AHU, if it doesn't need too much heat, it will only redirect the heating agent back into the return. You will have a three-way diverter valve. In our case, we'll allow the heating agent to go to the heat exchanger, and then the air will start to heat itself because this area will become very hot. So this area will become very hot, and then obviously this chamber is hot, and the air from this chamber is sucked by the fan and sent into the building. When the temperature will be reached, then the temperature can be the heating agent can be slightly restricted, not totally, slightly. But then if you will reach a point where the temperature grows and grows, then you will have a total restriction, and you have the entire quantity of the heating agent redirected, and then slowly the air will cool down. So this is it. Is quite simple. What I want you to remember instead, couple of things. One, as you see this yellow spot, this is a differential pressure switch. Inside this supply air chamber, the pressure is negative, and inside the fan in a duct, the pressure is positive. This DPS will sense this and it will send an input to the BMS. That's why the BMS knows the fan runs. If the fan is not running, then you have to check. If you have a broken motor, the inverter is faulty, the belts are broken, the pulleys are broken, the scroll is broken. But if the fan is running and it's all okay, you have to check the BMS. The BMS can be damaged, or the clear little tubes which collect data about the pressure can be blocked with dust, can be clogged. The same thing applies for this extractor fan. The filters got an analog DPS which reads the value of contamination. That's another story, we'll talk some other time. But guys, what I wanted to tell you, it's just that the AHUs are very simple. If I will speak about this control and inverter with another occasion, but so far I think this is all about this air handling unit. So I think it was quite easy for you to understand, and I hope you enjoyed this video. You can subscribe to my YouTube, and I'll get better and better, and I'll explain this better and better. Criticize me as much as you want. I really love other people's opinion. I do respect technicians, and I think I will treat everything constructive. And what can I say? Thank you so much for watching my video, and I'll see you soon with other videos. Thank you so much.